Hello and welcome to the Hydrogen Podcast, where we explore the latest advancements, challenges, and opportunities in the world of hydrogen. I'm your host, Paul Rodden, and today I'm excited to be joined by Bryan Glover, the Chief Technology Officer and Growth Officer at Honeywell Energy and Sustainability Solutions. Honeywell is a global leader in developing cutting-edge technologies for the energy sector, with a century of expertise in refining petrochemicals and now hydrogen solutions. Bryan has over 35 years of experience at the company, and he has now helped lead Honeywell's work in spearheading initiatives that are shaping the future of hydrogen. From advancing production technologies to solving infrastructure challenges, they are at the forefront of the energy transition. Bryan, thank you so much for joining us today.
Hey, well, Paul, I'm really happy to be here and happy to be able to talk with you today.
Fantastic. So, to start off, can you share Honeywell's vision for its role in the rapidly evolving hydrogen economy?
Yeah, in terms of Honeywell, we've got a broad strategic focus at Honeywell on three large megatrends that we see as, sort of critical to shaping the future. And, given Honeywell's position as a large industrial company, those include the future of aviation, the future of automation, and energy transition. And it's interesting that hydrogen, in a number of ways, and we'll probably dive into that a little bit deeper as we get going, it's focused on the future of energy transition, but it actually intersects with those other two megatrends as well in one way or another. So it's really touching all of them, and it's become really an important strategic thrust at Honeywell. And we're actively engaged in developing technologies that can support the adoption of both the production of hydrogen and also sustainable uses of hydrogen once it's produced. And I think we, like many in the industry today, see hydrogen and especially clean hydrogen as being critical to development of future economies, whether it's in chemicals or energy. It's going to bridge across all of those. And so we've really been working on a range of technologies that can support the growth of multiple sources of clean hydrogen. And we're excited actually to see that future taking off already, right? One example that we've been really excited about is our participation in the ExxonMobil's clean hydrogen project at their Baytown facility that's going to produce a large amount of low carbon hydrogen right here in the US. And that we've provided carbon capture and hydrogen purification technology for that. And that carbon capture technology, once that unit's up and running, is going to capture about 7 million tons of CO2 annually from that unit, which is equivalent to the emission of about 1.5 million cars. So it's a large, significant project. And it's one of those things that we're very excited to be partners and providing technology and excited to see that project move forward.
What industries or sectors do you see as the biggest drivers of hydrogen demand, and how is Honeywell positioning itself to serve them?
It's really interesting. There's a lot of talk and a lot of buzz about hydrogen. And I think there's two broad visions for hydrogen in the future, right? One is a critical chemical for industrial purposes, which is the primary use of hydrogen today. And the other is as a store and transmission source for energy.
Mhm.
And so, I think the two avenues that you see are producing clean hydrogen for things like refining and petrochemicals, where hydrogen consumption is important in order to transfer molecules to make the things we want, for production of ammonia, for production of clean methanol. And then the other is as an energy source, particularly for hard to abate industries where high temperature thermal energy is required or something like that. We certainly see a future where the demand for clean hydrogen grows first in that chemistry space and the industrial chemical places whether it's fuel production or chemicals. And then as the cost and availability of hydrogen increases, I think we'll see more penetration into hydrogen as an energy carrier.
Mm.
But in terms of where we see it, today, we see it in refining and petrochemicals,
Right.
whether it's for producing cleaner transportation fuels or initially today for renewable diesel and sustainable aviation fuel, where hydrogen input's required. We see strong demand for clean hydrogen to go into those applications today. Ammonia production, we're seeing projects that are using clean hydrogen for ammonia production from natural gas, in this case as a chemical, but in some cases also as a fuel. And I think we're seeing the start of clean hydrogen used in methanol and a little bit, spotty here or there in heating applications or in production of steel, places like that. But I think that's going to take a little bit longer for those to become as big as it can be for chemical uses.
I agree. How does Honeywell assess current market demand for hydrogen, and how do you anticipate it evolving over the next decade?
At the moment, what we see right now is, within today's hydrogen production, I don't know, somewhere around 70, 80 million tons. We're seeing some slow and steady interest in moving towards green hydrogen sources for those existing chemical opportunities. But then the longer term outlook, and I think this is probably what we'd all like to have a better handle on, but we do see tremendous demand for hydrogen going forward. And here we tend to look to industry sources to really understand where it's going to go. And some of the key places we might look, Hydrogen Council or World Bank, I think peg hydrogen growth to be somewhere between 5 and 7 times over the next 30 years. So I think there's strong view that there's going to be hydrogen demand growth significant. A lot of that's going to depend on cost and availability. A lot of it's going to depend on acceptability of sources, whether blue hydrogen or green hydrogen
Right.
is acceptable as a source of clean energy. But that's what we see. I think the big challenge now is really in terms of cost. If we look at renewable hydrogens or green hydrogen, I think most sources today would peg that cost at maybe $4 to $6 or $7 a kilogram, depending on cost of energy that's used, and that's quite a bit higher than the cost of gray today, which is a little bit of a gating factor right now. We see blue hydrogen availability coming in below that, I think much closer to gray in places where blue is acceptable, and I think the availability and the cost are the things that are going to ultimately set the rate of growth for hydrogen. We'll probably get to that 5 to 7 times one way or another, but I think the question of what the curve looks like over the next 5, 10, 15 years, is it a quick uptake or is it a slow uptake rising towards the end? I think that remains to be seen. But I think we, from the perspective of Honeywell, we at Honeywell are, here trying to do our best to make that hydrogen available to people through technology at the lowest cost that it can be produced at the fastest pace that we can get technology out, so that it's less dependent on availability of technology and more dependent on really just what the economic demand for the hydrogen is.
Could you highlight some key milestones Honeywell has achieved in hydrogen development so far?
I'm kind of going to go way back, and I won't take too long, but Honeywell's been involved in production of hydrogen for a long time. And probably our key participation goes back to the mid 1960s, actually 1966, when we introduced the first pressure swing adsorption unit for hydrogen purification. So people had been making hydrogen through reforming or partial oxidation of one sort or another for a long time. But being able to clean it up to high purity through pressure swing adsorption was a significant innovation driven by UOP at the time. And today, that technology has grown to the point that it's used very broadly. We've delivered over 1,000 PSA units worldwide to support that. That may have been sort of one of our early forays into hydrogen production, but we continue to focus today on innovation. And the things that we're focusing today are in the area of blue hydrogen, providing carbon capture solutions that can support blue hydrogen production from new and existing hydrogen plants, whether it's existing steam methane reforming unit or whether it's a new autothermal reforming unit. We've got technologies that can pair with those units in order to give you, maximum economics and maximum performance in terms of producing the hydrogen, capturing it, and then maximizing the yield out of those. So one of the key things is by including carbon capture technology with purification technology, we believe we're able to produce a higher yield of hydrogen out of a reforming system than a less integrated system. So we're working there. We've done a lot of work in catalyst-coated membranes, and we're not intending to be an electrolyzer company, but we are a membrane company, and we've been providing membranes in the natural gas area for decades, and so we're a leading provider of membranes actually for CO2 separation from natural gas. So we've been helping people recover CO2, in some cases for sequestration or reinjection, for a long time. And so we've been putting that membrane know-how to work in the area of catalyst-coated membranes. So we're a catalyst company, we're a membrane company. It seemed like it was a natural connection to bring those together. So we've produced catalyst-coated membranes that we've demonstrated internally and with some interested third parties that can produce about 30% more hydrogen per surface area than membranes that are in the market today, which ultimately can drive to a smaller, more compact, lower cost electrolyzer, we think, about the same 29 to 30% reduction in capex due to process intensification for systems that use those membranes. So we're excited about that. We're moving to commercialization with those. We're moving to commercialization with simpler, lower cost technologies that can do the cleanup and the final polishing and purification of electrolyzer hydrogen. And then we've also done work and we've launched a technology that's available for transport of hydrogen, a liquid organic hydrogen carrier technology. So they're very active space for us, and there's a lot going on today. And if anything, accelerating our efforts there to really try to bring comprehensive solutions to people.
Efficiency and cost are critical in this industry. How do these innovations improve operational efficiencies or reduce production costs?
That's the challenge, because I think we're always looking for, how can I make the new thing for less than the old thing? And I think when we start to talk energy transition, at least as we get started, we're really talking about how can I minimize the cost impact of the new thing. So one example is sort of what I just mentioned around catalyst-coated membranes for electrolysis. And that's really focusing on the efficiency of the membrane and trying to get the maximum current density across the membrane and be able to make the electrolyzers as small as possible. Mm-hmm. The other areas where we're focusing on cost is trying to, in general, bring end-to-end solutions to the extent that we can. If I look at, in the case of like blue hydrogen, trying to make sure that the solutions that we provide with carbon capture and then with purification, that we maximize yield when we do that, and that we've got systems that are designed to be well integrated into the hydrogen production units themselves. So we're not a hydrogen technology company ourselves. Mm-hmm. There's a number out there, and we've been working with several of them. And in all cases, what we've really tried to do is to make sure it's not just two technologies that happen to be sitting next to one another in a plant and are connected by a pipe, but two technologies that are thoughtfully put together in order to minimize both the cost of construction, but the cost of operation in terms of the energy and cost inputs as well as the yield that comes out of it. The last thing that I would add to that is really trying to design for maximum reuse of existing assets. And so, for instance, in blue hydrogen, there's the opportunity to decarbonize existing steam methane reforming units, right? Which can, in some cases, provide a more cost-effective solution for producing blue hydrogen than maybe an all-new build. In terms of our work with liquid organic hydrogen carrier, which is a way to take the hydrogen and bind it with an organic molecule to be able to put it in, sort of standard shipping. One of the great things about that technology approach is there's potential to do significant reuse of existing facilities for the combination of the hydrogen with the hydrocarbon and then the recovery of the hydrogen with the hydrocarbon. And then it can also take advantage of existing shipping assets that are available for hydrocarbons. Mm-hmm. So really two-pronged approach, right? Trying to do our best to come up with the most cost-effective solutions, but where there's an option to reuse existing assets and clean them up, that's another great opportunity as well.
What initiatives has Honeywell undertaken to scale green hydrogen production, and what challenges are you addressing in that space?
So touched on these a little bit already with the catalyst-coated membranes. That's a big part of it. I mentioned earlier just a little bit about purification. So, even green hydrogen requires drying. It may require a little bit of additional cleanup. So working to bring to the market fit-for-purpose solutions, cost-effective, that scale with green hydrogen. A lot of green hydrogen projects that we may see going forward will be small in scale at first. A lot of hydrogen cleanup and purification systems have gotten to the point today where they're really designed for large industrial scale. So to be able to offer solutions that fit well with point source production of hydrogen that's much smaller than many industrial applications, I think is important. Transportation is another big thing, whether it's supporting transportation of hydrogen in pipelines or supporting transportation of hydrogen through shipping, as I mentioned already, bringing technology that can, if green hydrogen is not going to be a point source production, then bringing technologies that can help support the transportation of green hydrogen from low-cost producing regions to consuming regions, I think is very important. And there's some other adjacencies as well that we've been working on. One is energy storage, where a key part of renewable hydrogen, green hydrogen, is having that renewable source of energy. And it's not a practical situation to say, well, I'm gonna design an electrolyzer that runs while the sun shines. So being able to provide energy storage solutions that can take renewable energy and turn it into a steady source. We provide both lithium-based packaged solutions through our industrial automation business and through our energy and sustainability solutions business. We're working to introduce long duration flow battery technology as well, both of which can be paired with renewable hydrogen in order to make a more stable system. And then control systems as well. One of the things with renewable hydrogen is you end up with, even a medium-sized plant running a small fleet of electrolyzers. And within Honeywell, our process solutions business, which is one of the premier control system providers in the world today, has control system offerings that can integrate all of the elements of a green hydrogen plant together to provide a very controllable system and potentially to provide sort of fleet management over a number of point source renewable hydrogen assets as well. So there's a lot that we're working on, and I think there's a lot that can be done to really bring this to an industrial scale.
Carbon capture is a crucial component of low carbon hydrogen. Could you share some insights on Honeywell's latest advancements in carbon capture technologies?
At Honeywell, we've been working on carbon capture for decades and decades and decades. And, with our background primarily in the energy industry, whether it's refining and petrochemicals or natural gas, we've historically thought of it as acid gas removal, if you will, taking CO2 and or other acid gases out of either refinery streams or out of natural gas streams. And so we've had within the company a significant basket of technologies that were originally designed for carbon capture, maybe in somewhat different applications, but that we've been able to readily apply to today's landscape of carbon capture, whether it's for pre or post combustion situations in refining, petrochemicals, gas processing, power, cement, or steel, or other industries out there. We have technologies that are not only suitable, but we think are world class in terms of addressing those solutions. So we've got cryogenic fractionation, which we've seen pairs oftentimes very well with hydrogen production for blue hydrogen. That's the basis of the project with ExxonMobil in Baytown. But some advanced liquid scrubbing systems as well. We've got something called our ASCC, our advanced solvent carbon capture system, which can be used in pre-combustion, but also broadly in post-combustion scenarios for scrubbing different kinds of vent and flue gas for CO2, and we think is the low-cost solution in the industry today. Adsorbents, and some of that comes out in hydrogen purification, but there are applications where adsorbents might be the right play, and we're a significant adsorbent company. And then also in membranes. Natural gas, historically, membranes for high CO2 gases have been the way to take that CO2 out. Membranes can have a play in some places as well. And so we've been, moving to adapt and improve that technology or those technologies where they can fit for, as I say, both pre and post combustion applications. And, have felt that generally they're best in class solutions and really can cover a very, very broad spectrum. As I say, there's the project with ExxonMobil. There's another project that was announced a while ago, somewhat similar. It's with Wabash Valley Resources in the U.S., where they're looking at gasifying materials, including biomass, in order to make hydrogen. And same thing there. This incorporates CO2 fractionation system originally designed to take CO2 out of natural gas, but the CO2 fractionation system along with some molecular cleanup through adsorbents in order to produce clean hydrogen out the back end. But essentially, whatever the scenario is, we can probably find a solution, but are continuing to pump a lot into development because it's really about making the technology available and making it fit the application at a cost that makes sense in order to be able to drive decarbonization.
As the hydrogen industry grows, infrastructure is often cited as a major hurdle. What do you see as the primary challenges, and how is Honeywell addressing them?
Yeah, I'd agree completely that infrastructure is a big hurdle here, with a couple of notable exceptions, U.S. Gulf Coast and
Mm,
maybe some places in northwestern Europe. Hydrogen is historically consumed where it's produced or
right.
in close proximity, right? There are examples in the U.S. Gulf Coast where hydrogen is transported over reasonable distances, but that's not the norm. And so, a key part of driving a hydrogen economy is, in many cases, is going to be developing capabilities for transport and storage of hydrogen, which may or may not be there today. It's also going to be trying to develop these clean hydrogen sources for the minimal cost. And so anything that can maximize either localization, so
Mhm.
think about renewable hydrogen, green hydrogen, it's great for a localization play because if you've got access to clean electricity, you can produce some, small amounts on site as long as we can make sure that the cost at small scale doesn't dramatically exceed the cost at large scale for renewable hydrogen, then as long as electricity supply allows, being able to produce locally is sort of one way to take advantage of minimal impact on infrastructure. But then where we're going to build infrastructure and transport hydrogen, having technologies available that can maximize the reuse of existing infrastructure is critically important. So liquid organic hydrogen carrier, for us, that's a big play
Yeah.
because we take the hydrogen, we combine it with toluene to make methyl cyclohexane, can ship that on relatively standard shipping that can handle hydrocarbon liquids. You
Mhm.
strip the hydrogen off the other end, get toluene back, the toluene's got to be returned. But the infrastructure to support that largely exists because there's refining assets that exist in the world today in hydrogen consuming regions or future hydrogen consuming regions
Mhm.
that are surplus and maybe have been shut down and can be adapted for a relatively low cost. The ability to put the hydrogen into the hydrocarbon at the producing end,
Mhm.
there may be assets there that can be adapted, or if not, that's a relatively low cost asset that can be built. And so, really looking at technologies like that, the ability to add carbon capture to existing hydrogen assets, working with companies that are getting into the CO2 transport and sequestration business in order to help customers find opportunities to locate blue hydrogen production sites
Mhm.
near places that there's existing pipeline access, perhaps, surplus natural gas pipeline capacity or something that can allow that CO2 then to get back to sequestration sites. I think that's all part of the picture. And
Yeah.
those are all areas where we, either through our technology or developing partner relationships, are trying to bring together technology and an industry ecosystem where we can help customers who want to develop hydrogen assets to develop their projects in a more seamless and in a simpler way so that these things can move forward at the pace that people desire.
Yeah. And you just touched on something I'd like to take a little bit deeper if we can. Your work with liquid organic hydrogen carriers, or yeah, LOHCs, really is fascinating. Can you explain how this technology facilitates long distance hydrogen transport?
I think probably a lot of us have seen or read a lot about the challenges of hydrogen transport. You
Mhm.
can there's multiple ways that you can approach this. You can liquefy the hydrogen, you can put it on a boat, but that, because of the extreme cryogenic nature of that, a lot of complexity, a lot of costs, a lot of boil off along the way. There are other ways to transport hydrogen. Ammonia is one of them. It has some advantages. It also has some challenges. The liquid organic hydrogen carrier is the system that we think for long distance transport of hydrogen makes the most sense. One, from just a basic cost and simplicity of doing it on an ongoing basis, but two, from a capital intensity and capital cost, because it does allow for significant, as I mentioned a couple times, significant reuse of existing assets. And so for us, this was a really good fit because as Honeywell, we're a company that for decades has been a leader in the technologies that are required to do this. So the two technologies that you require are essentially hydrocarbon saturation technology to be able to put the hydrogen into the carrier. In
Mhm.
this case, our carrier is toluene slash methyl cyclohexane. So at the hydrogen insertion end, it's taking toluene and saturating it at low cost and high selectivity to methyl cyclohexane. You want all of your hydrogen and all of your toluene to convert to methyl cyclohexane and not have cracking or any byproducts or anything else.
Mhm.
That hydrocarbon saturation field is an area that Honeywell has a lot of experience, has been playing in for a long, long time. Related technologies that are used at industrial scale are, for instance, benzene saturation to produce cyclohexane that ultimately goes into the nylon chain and others, or just general saturation of aromatic compounds in refining applications.
Mhm.
So a lot of experience with that and a lot of repurposable assets. On the other end is the dehydrogenation, so removing the hydrogen for the methyl cycle from the methyl cyclohexane and again producing a pure hydrogen stream and a pure toluene stream. And that really is essentially just a narrower form of catalytic reforming, or what we at UOP would call in Honeywell platforming.
Mhm.
And so, as the company that developed that technology originally back in the late 40s, and as the leading provider of that technology, as well as other industrial dehydrogenation technology for propylene and butylenes, again, it was a natural fit. And in developed regions, areas like Japan, there's a number of idle catalytic reforming units that are already configured in a way that they can take toluene and dehydrogenate it, I mean, methyl cyclohexane and dehydrogenate it into toluene. So there's ready availability of units that could be revamped and repurposed in order to do that. And that's really the two ends of it. Again, a little bit like the carbon capture, it's a natural fit for technologies that we've worked on for decades and have a deep understanding of, and then can optimize for this application. So it's very exciting to us that the solution is fairly straightforward, involves a lot of asset reuse, which by its
Mhm.
nature is sustainable because the equipment is already there and could get up and running relatively quickly. And the assets are where they need to be, right? It's the consuming countries that, places like Japan, maybe places like Korea, that actually today have some excess capacity, these old assets. It seems like rare in the world that an idle asset is actually where you want it.
Mhm.
But this is a great case where potentially idle assets are already where they need to be and where customers would want them to be.
Let's talk about risk for just a little bit. Operational risks are always a concern. How does Honeywell approach mitigating risk in hydrogen-related operations?
So for us, I don't want to understate it and I don't want to trivialize it, right?
Mhm.
Because always dealing with hydrogen, it is something you have to be careful with. But
Right.
I think the good thing for us is hydrogen and either producing or consuming, I'll say processing hydrogen, has been core to much of the technology base that Honeywell has developed over the years, as well as some of our own operating plants as well. So much of the world of refining and petrochemical technology today has to do with either removing hydrogen from molecules. Things like catalytic reforming for gasoline is really about turning aliphatic materials into aromatic materials. So extracting hydrogen, and that becomes a principal source for hydrogen use in refineries. Things like propane dehydrogenation. Again, you're taking propane, removing the hydrogen and producing high yields of propylene, or hydroprocessing technologies, things like hydrotreating or hydrocracking in particular, where you're really trying to transform molecules by putting hydrogen in them to either saturate them or go ahead and break bonds and break them down into smaller components. So for us, in terms of developing technologies and hydrogen management, between process technologies that we've been providing to the world for a long time, hydrogen purification equipment like PSA, or membrane systems. We've been doing that for a long time, so we feel that we've got a lot of deep understanding on how hydrogen needs to be handled in order to handle it safely. And
Mhm.
we're incorporating that plus all the new learnings we have into the systems that we design. But beyond that, given that Honeywell is more than a technology company, that we're a controls company, we're a sensors company.
Mhm.
We have sensor technology that's available that can detect hydrogen leaks and allow you to be able to quickly action on those within a process plant. And we have advanced control technology that's able to control the entire process plant in order to make sure that we're managing hydrogen, and if we do have a problem, we're able to shut down in the safest way that we can and be able to manage the hydrogen and get it to a safe place. So I would say for a company like Honeywell that's been dealing with hydrogen industrially for a long time, we feel comfortable with it, and we feel like we know how to make these systems safe.
Mhm.
And I think that's actually a really big advantage with technologies that we're developing and we're promoting, because it does come from that deep background rather than, it's not as if we're somebody that said, hey, this hydrogen space looks interesting, let's invest a little money and try to figure out how to produce some new hydrogen production technology without having decades of experience in terms of, safe and code compliant management of
Yeah.
hydrogen containing systems.
Earlier, you mentioned some partnerships that you have. You also recently partnered with Johnson Matthey to advance lower carbon hydrogen solutions. Can you tell us more about the goals of that collaboration?
Our work with Johnson Matthey is, I mentioned earlier in terms of blue hydrogen, really the value of trying to bring an integrated solution. So our carbon capture technology, along with our hydrogen purification technology,
Mhm.
and Johnson Matthey's low carbon hydrogen, what they call LCH, their technology, we've been working together to be able to offer customers who want an integrated solution. Not everyone does, but for people that want an integrated solution, a well integrated solution from the front end through autothermal reforming, through the carbon capture and the hydrogen purification, a system that's designed to work together. So the ATR has been optimized in order to work with hydrogen recovery system, which isn't necessarily trivial, because like in this case, you've got a very hot side and a very cold side, for instance. So you've got an autothermal reformer running at really high temperatures, and then you've got a cryogenic system on the back end in order to remove the CO2. And so there is a significant challenge in integrating those technologies in a way that minimizes energy consumption and recovers all the heat that you possibly can, and yet allows you to get to cryogenic temperatures on the back end. So getting to integration and getting to the lowest cost of operation, which also results in a low carbon footprint, is really important there, and our ability to work together to drive towards these integrated solutions that, from a customer perspective, are also integrated in that they're designed to work together. It's not that customer has to buy part A from one supplier and part B from another supplier and then hope that they actually work together. There's an ability for us to work collaboratively with Johnson Matthey
Yeah.
to provide not just the design, but then service for that end-to-end situation. And what we see today is increasingly people that want to produce hydrogen, they want to produce hydrogen.
Mhm.
In the old world that we've lived in, Honeywell, which is the refining and petrochemical world, refiners put together a complex refinery, and then they go about day to day optimizing that operation for the feed, their configuration, the products that they need to run. And so generally in the refining space, what an oil refiner is trying to do is use their configuration, their special capabilities, and their knowledge to get the best outcome every day.
Right.
For people that are making hydrogen, right, they're going to have a stable feed. It's probably natural gas in the case of blue hydrogen. They want the natural gas to come in. They want the hydrogen to come out. They want it to run steady, and they want it to produce as effectively as it can every day, day in and day out. And that's a very different sort of paradigm. And so being able to bring an end-to-end solution is really important to that, because that's what the customer values. They're not trying to optimize to different kinds of hydrogen every day or different feedstocks. They want to be able to, optimize and make that thing run better and more reliably every day. But that means it needs to be well integrated to begin with, and then they can go from there.
And along with Johnson Matthey, you also partnered with ExxonMobil, and they've deployed your CO2 fractionation and hydrogen purification system for its carbon capture efforts. What role does this technology play in advancing their projects?
Yeah, so in their project, it's an autothermal reforming based hydrogen project, and it needed a carbon capture component.
Mhm.
So, as they evaluated options, they liked what they saw with our option. And in that case, the licensor for the hydrogen technology was Topsoe, and our ability to work with Topsoe again to bring to ExxonMobil a solution that they felt was optimal for their needs was critical. And there's multiple ways that you could put carbon capture on the back end of an ATR. It could be through a solvent system, could be with CO2 fractionation, there are probably some other systems out there. But when they looked at it and looked at the integration, they saw that the CO2 fractionation was the more effective system in order to go with that. And that CO2 fractionation, we work to make sure it pairs well with the ATR, but then we also make sure on the back end that in terms of the hydrogen purification, that it's not just a standard run-of-the-mill hydrogen purification PSA system. It's a PSA system that's specially integrated to work with the particular way that the CO2 fractionation system works and take advantage of or create some synergies between those two technologies. So it's a little bit more than the CO2 recovery system itself. It's the CO2 recovery system in combination with the PSA system on the back that really brings the unique capability here and the unique integration. So, I think we all know that when you have multiple processes in a row or in combination with one another, the more you can integrate them and the more you can focus on how they work together, the more value you're going to get out of it. And here, there's trade-offs on the front end on how CO2 would work with the ATR. There's trade-offs on the back end. Potentially there is some balancing that you need to do between getting the best integration with the front end and the best integration with the back end. So again, it gets back to that idea of I want to integrate the system and I want to optimize it end to end in order for best performance rather than to do local optimizations and say, okay, well, I've got the best possible integration of hydrogen purification with CO2 fractionation, but that led me to doing something that maybe is not optimal in the way I integrated it with the hydrogen production. So being able to see that end to end, we see big value there.
And Honeywell also acquired Air Products LNG technology. How does this acquisition enhance your capabilities in the hydrogen sector?
This was an opportunity for us, I think, to really focus on, again, bringing deep solutions to the industry and focus on that megatrend of energy transition. So we've been a player in refining, we've been a player in petrochemicals, and we've been a player in natural gas for a long, long time. But in natural gas, which would be a typical feedstock for hydrogen production, our participation in natural gas historically has been in the cleanup of the natural gas, in the production of natural gas, separation of natural gas liquids, cryogenic separation of natural gas liquids, and then in the cleanup of those liquids and in the processing of those liquids. So Honeywell was in this where as gas came out of the ground, we offered technologies to remove sulfur, remove CO2, remove mercury, remove other contaminants, and make it clean and ready to go into LNG. In fact, UOP was already providing pre-treatment for about 40% of the world's LNG capacity in order to get it ready. And then through our Ortloff and UOP Russell businesses, we were providing technology for separation, recovery of natural gas liquids, and then separation and purification of the natural gas liquids once they're taken out of natural gas. And with technologies like our propane dehydrogenation, and butane dehydrogenation, and some others, really we're providing large outlets for monetization of those natural gas liquids. So we're playing broadly in that chain, but we weren't playing directly in the liquefied natural gas space. So that acquisition and bringing in LNG technology really allows us to complete that portfolio. And again, as I was mentioning, in terms of integrated solutions, really bring what we anticipate to be hassle-free, well-integrated solutions that are best in class for, raw gas all the way through LNG and all the way through pipeline gas and all the way through natural gas liquids and monetization of the natural gas liquids. So that really fills out that network and allows us to be a full provider. Some of that LNG may find its way into hydrogen production, initially gray, but then maybe blue in some parts of the world. But then it also allows, I'll say, sort of greater participation and greater support of the build out of natural gas infrastructure as we go forward. And, we really see, like I think most of the world, is natural gas as being an important transition fuel, especially there's a lot that people want to do in decarbonization, whether it's with hydrogen or things like sustainable aviation fuel, renewable diesel. But there's an awful lot to be done really in the short term just to support global energy systems to get to the lowest possible carbon intensity fuels where we're still using fuels. So,
Right.
support of LNG to move coal out of power production in other places. I think there's a lot of runway for that. And the reduction in carbon intensity just by switching to natural gas can be significant. So we see a lot of value in that. Some of it focused on hydrogen, but a lot of it just supporting energy transition in general and help the world drive to where we all want to go.
And lastly, your partnership with Electric Hydrogen focuses on electrolyzer technology. What are the objectives with this collaboration, and how does it fit into Honeywell's broader hydrogen strategy?
Yeah, so our broader hydrogen strategy, as I mentioned in the beginning, our goal really as Honeywell is to help bring capabilities and technologies to the market that support, let's say, the world's desire to move more towards hydrogen-driven economy. And so we've been focusing heavily on internal investment to support that. But we've also been doing some external investment to support that. So in June of 2022, our Honeywell Ventures platform made an investment in electric hydrogen. We've done an assessment and we thought that was very promising technology. So we were part of a Series B financing round and contributed to the financing that went at the time. So we're supporting the development of them, looking for any opportunities to collaborate with them. But really, this is part of our efforts to support the development of the hydrogen infrastructure for the world and looking to help support technologies that we think can have a strong impact.
Bryan, this has been fantastic. Thank you so much for joining us today and sharing these incredible insights into Honeywell's initiatives and contributions to the hydrogen industry. Your team's work in advancing technologies and addressing challenges is truly inspiring.
Well, thank you, Paul. I appreciate the chance to talk with you today. I've enjoyed the talk, and it's been great to sit down and do this. So thank you for inviting me.
Absolutely. And for our listeners, if you'd like to learn more about Honeywell and their role in shaping the future of energy, visit their website at www.honeywell.com. Until next time, I'm Paul Rodden. This is the Hydrogen Podcast. Thanks for tuning in.